Hello Nines! We're going to take a look at our last topic in Chapter 9 Math, solving multi-step linear inequalities. We're going to get right into it with this problem here. We have negative 2 times x plus 3 is less than or equal to 10x plus 18. So there's two ways we could start off in solving this problem. The first is we could divide both sides by negative 2, which is a valid strategy, or we could distribute and then go from there. I think I'm going to distribute to start off the bat, even though the other method might be easier. So I'm going to take this 2 and I'm going to multiply it by both terms inside the brackets. After I do that, I'll get negative 2 times x is negative 2x. Negative 2 times 3 is negative 6, less than or equal to 10x plus 18. At this point, we're kind of in a letter, land, number, nation situation here, so I'm going to look for the most x's, because that's the variable I'm dealing with in this equation. If I have 10x here and negative 2x here, 10 is the greater number, so I'm going to call this my letter land, this side my letter land, this side my number nation. So I want to get all the letters to this side. Here's a letter that is not on that side. I want to bring it over. When it crosses the border, when it crosses this inequality sign, same thing as with an equation, it's going to change signs. So it was negative 2x here. I bring it over, it's now positive 2x. All the numbers are going to be over here. Had a negative 6 here. I'm going to bring this positive 18 to the other side. It's now going to become negative 18. I haven't had to switch my inequality sign because I haven't multiplied or divided by any negative numbers, so this is still the same. Okay, now I'm just going to go negative 6, take away another 18, is going to give me negative 24. Less than or equal to 10 x's plus 2 x's is going to give me 12. And this, at this point, I'm going to divide by 12 on both sides. To get negative 2 is less than or equal to x. If I wanted x to be written on the other side, I could also think of it as x is greater or equal to negative 2. The mouth of the alligator, if you kind of think about your greater than less signs like that, is opening towards x. So on this side, it needs to open towards x there. But you could just leave it like this right off the bat. So I got x is greater or equal to negative 2, or negative 2 is less than or equal to x. Both mean the exact same thing. And now I'm going to do a check. And so, like we learned in our last topic, if I'm going to do a check, I need to check two things. I need to check the boundary point and the range of values. So to check the boundary point, I'm going to start with my original equation, except everywhere I see an x, I'm going to replace it with negative 2. And again, I want to see if the left-hand side and the right-hand side are equal. So I have negative 2 plus 3. I just replaced this x with a negative 2. Then I'm going 10 times negative 2 plus 18. Okay, I'm going to start with brackets first. Negative 2 plus 3 is going to be 1. And that's going to leave me with the 1 here times negative 2. The other side is 10 times negative 2 is negative 20 plus 18. Negative 2 times 1 is negative 2. Negative 20 plus 18 is also negative 2. The left-hand side equals the right-hand side. I know the boundary point is correct. So now I'm going to test the range of values. So my solution said x is bigger than, has to be bigger than or equal to negative 2, but now I want to choose a value of x that's bigger than negative 2. I talked about in our last video that if you can pick 0 as one of your possible choices in your range of values, you should do that because it's easy to add things to 0, and multiplying and dividing by 0 is easy if Actually, dividing things by 0 is impossible. But for adding in and subtracting and multiplying, it works quite nicely. So this is a case where 0 is bigger than -2. So I'm going to use 0 to check my range of values, and hopefully you see why 0 works out nicely. So now I'm going to go -2. I'm replacing x with 0 plus 3. And now I'm looking for this side to be less than the right side. 10 times 0 plus 18. So again, you can only choose 0 if it works. In this case, it does. And it's going to work out great because 0 plus 3, that's an easy one for me to do. It's just 3. 3 times -2 is -6. 10 times 0 is also a super easy question for me as well, because anything times 0 is 0. 10 times 0 is 0, plus 18. So now I just got to check if this is true. Is -6 less than 18? It is. And so the range of values is also looking pretty good. Okay, next one that we want to solve and verify. Again, we're kind of into a letter land number nation scenario, and so I have 10 x's on this side, and so I'm going to move this -2x to the other side to become plus 2x. I have 5 here. I'm going to bring this plus 29 to the other side. It's going to become -29, and I get -24 here and 12x. Again, divide both sides by 12. And I get -2 is greater than x, or x is less than -2. So to verify again, I want to use this value and see if the left-hand side equals the right-hand side. So for my boundary point check, I'm going to go 5 minus, 2 times -2. We're going to check if it's equal to 10 times -2 plus 29. -2 times -2 is 4. 5 plus 4 is 9. 10 times -2 is -20. Plus 29 is 9. The boundary point is looking great. For the range of values, I'm just going to pick any value of x that is less than -2. I'm going to use -5. Again, there's many numbers we could choose from. So I'm going to go 5. 2 times -5. Hopefully that's going to be greater than 10 times -5 plus 29. Okay, -2 times -5 is positive 10. 10 plus 5 is 15. Is that greater than 10 times -5 is -50? Plus 29 is going to leave me with -21. Is 15 greater than -21? Yes, it is. The range of values is also good. That's really it. We're just using some of the skills that we've already acquired in solving linear equations. We're just applying these same multi-step strategies to linear inequalities. Again, one key difference is that if you multiply both sides by a negative number or divide both sides by a negative number, you have to flip the sign. That still applies. Other than that, it's very, very similar to solving linear equations. And so hopefully with a little bit of practice, you guys will become experts at this